Let us find out the relationship between potential difference across a conductor and current through it in an electrical circuit. We have taken a conductor made up of nichrome wire in the form of a coil. It is connected to the circuit as shown. Since we have to find the potential difference across this conductor, a voltmeter is connected in parallel. To find the current flowing through the conductor, an ammeter is connected in series with it. A cell and plug key is connected in the circuit. Close the circuit by inserting the plug key. Current starts to flow through the circuit. The voltmeter is showing the potential difference across the nichrome wire as 1.5 volt, and the ammeter is showing the current flowing through it as 75 milliampere. Mark this point in the V versus I graph. Add a second cell in the circuit. The voltmeter shows 3 volt of potential difference across the nichrome wire, and ammeter shows 150 milliampere current flowing through it. Mark this point again in the graph. Similarly, add a third and fourth cell in the circuit and mark the respective points in the graph. We can see that the V versus I graph is a straight line passing through the origin. The ratio of V and I in each case is the same. Thus, V by I is a constant ratio. Ohm's law is derived from this observation, and it is defined as the potential difference V across the ends of a given metallic wire in an electrical circuit is directly proportional to the current I flowing through it, provided its temperature remains the same. Thus, V by I is equal to a constant called R. R is a constant given for a metallic wire at a given temperature and is called resistance. The SI unit of R is ohm.